Welcome to a new chapter in our CLIL course Physics. In this chapter we will be talking about electric energy and voltage, in this case potential energy. Now it is a very abstract chapter and not an easy one to understand, and I will be making comparisons quite often to another form of potential energy you are more familiar with, potential gravity energy in this case. Now, the useful vocabulary we will be using is, well, potential energy is, of course, potentiële energie. Work in this case is arbeid. Displacement is a word you may not have heard of before. It's called verplaatsing. And homogeneous is, of course, homogeen. Now, in order to understand what is going on, we have to first discuss potential electrical energy. This isn't the first time you have learned about potential energy. An object with mass, for instance, could have a certain amount of potential gravity energy due to its height. Gravity would be the force that would perform work if the object was able to fall down, meaning it had any height compared to ground level. Work is what you get when a force causes a displacement in this case. Now, this is the equation I have written down. The amount of work equals the force that you use to make your displacement. That displacement is quite often known as delta S or delta X in some literature as well. So in case you've not heard of that one before. And the equation you used to determine how much potential energy you had, you used a specific formula, a specific equation for potential gravity energy. Mass times gravity field times height. And that height, h, equals the height compared to a reference point. In this case, ground level. This already makes it sort of different with electrical energy because we are going to have to discuss what we consider to be our reference point in these cases. For gravity, obviously, that's your ground level. It's going to be different for electrical energy. An object has a certain amount of potential energy if there is a force that can result in work, or a displacement caused by force. What other types of potential energy do you know of, or have you heard of? Well, there should be several that you can fill in here. It doesn't necessarily have anything to do with the chapter itself in this case, but you will have learned of gravity energy, of course, light energy, chemical energy. There are different types of kinetic energy is also a very important one. There are many different types of energy that exist, and quite often a certain type of energy will be transformed into another one in many physical processes. Now, in this chapter we will study a new type of potential energy. Why? You've got a force, and in this case it's not just any random force, it is in this case the Coulomb force. It can cause or perform work by displacing, in this case, a charge. Just like gravity could perform work by displacing mass. Right. Now the situation is slightly more complex compared to gravity when you compare electrical energy. The equation that we used only applies if the force remains constant, and gravity remains more or less the same when height changes. There's not that much difference in your g value, so it can be considered a constant. However, the Coulomb force is one that does change, depending on the distance between charges. There's only one notable exception in this case, and it will be the one that we we'll be using all the time, and those are homogeneous fields. In homogeneous fields, there is no difference in electric force dependent on your position in the electrical field. Okay? Now, let's talk about potential energy in this case. Let us take a homogeneous electric field, again, done to make it easy, where the two plates are a certain distance d apart. The electric field is always going from positive plate to negative plate to form the homogeneous field, right? In this case, we have a positive charge, Q, that is placed in the middle. What would the Coulomb force look like on this charge Q? Well, it is a positive charge, and in our previous chapter we saw that if this one is positive, your Coulomb force will actually go from, or have the same sense as your electric field E. Meaning, if the Coulomb force is going to perform work, it is going to displace the charge in the same direction. If this is the case, then we say that positive work has occurred, that the force will have performed positive work. Gravity can do that by dropping something down. Electrical potential energy, the Coulomb force, can do the same by bringing a positive charge towards the negative plate. You immediately can tell that this makes things more complicated than gravity, because in gravity, well, you were talking about masses, and those are always positive. However, charges can also be negative, meaning that you can have different types of potential energy. Now, what do we call the maximum or the height if we're making our comparison between electrical energy and gravity energy? Well, the height would be the distance measured from the negative plate in this case. Meaning that in this position, we would consider our potential energy to be 0. Why? Because your distance x is also 0. Now, what is your potential energy in this case? If we want to pour that into an equation. Well, the larger the charge in the middle, the more potential energy it will have. Why? If this charge increases, your Coulomb force will increase. So it is directly proportional to the strength of the electric field E in this case. Why? If we demultiply E by Q, we will know what the, in this case, Coulomb force is. So the more Coulomb force you have, the more potential energy this charge would have. And what determines the amount of Coulomb force that you have? Your charge and the magnitude of your electric field E. So those are the first things that increase your potential energy. What else increases the potential energy? The ability to be moved. Well, that distance x compared to your negative plate in this case. The further this charge is removed from your negative plate, the more potential it has to move, to be displaced. So it can perform more work if the distance is higher in this case. What is the maximum amount of potential energy this setup has? Well, that depends on the distance d between the two plates, of course. It cannot exceed the distance d in this case, meaning the potential electric energy that it has at most in this case is E electric field times charge times the distance between those two plates. that determines it.